everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 7C. Myself, Priyanshi Goyal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the International Conference on Machine and Computing Technologies for Sustainable Development, MCT4SD 2025, Manila, Philippines. The conference is being organized in a hybrid mode. The physical event was held day before yesterday in Manila, Philippines, and the virtual event is being held through Zoom today and yesterday, that is 12th and 13th of December 2025. Can someone confirm if I'm audible?
Yes, ma'am, audible. You are definitely audible.
Thank you so much. I hope you all will enjoy the knowledgeable and interactive sessions through the day. In this session, we will have 8 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. I request all the participants to kindly adhere to the timeline so that we can conclude the session on time. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. All right. Just before we start the session, I would like to introduce the chair for this session, Dr. A.R. Kavita. Dr. A.R. Kavita ma'am is a professor and head at the Chennai Institute of Technology, India, with 24 years of teaching experience in the fields of computer science and engineering and information technology. She has an extensive research portfolio and has published numerous papers in key domains such as the Internet of Things, cloud computing, and image processing, contributing significantly to advancements in these areas. I think ma'am is here. Okay, there's some technical errors, but she'll be joining us soon. So without further ado, we will be starting with the sessions. I would like to call upon the first presenter for today, uh, Sir T.S. Murugesh, to kindly present your paper titled A Bio-Inspired Cuckoo Search Algorithm for Control of a MIMO Process. Do we have you here with us, sir? Is anyone else from the team present?
No, ma'am. I am the first author, and I am going to present on behalf of myself, ma'am. My co-author Senthil Kumar is also there in Zoom meeting, ma'am.
Okay, yes. So,
Yeah.
is my screen not visible?
Let me share it. Let me share it, ma'am.
Okay, just a second.
Yeah. Is the screen
Yes,
now visible, ma'am?
your screen, no, sir, it's not visible yet.
Okay. Share application window. Is it now visible, ma'am?
Yes, sir, your screen is visible. Can you put it in slideshow mode? And
Yes, ma'am. Yes, ma'am.
thank you so much. You can start now.
Yes, ma'am. Good evening, everyone. I am Dr. T.S. Murugesh, and I am working as an associate professor in Department of ECE, India. My title is a bio-inspired cuckoo search algorithm for control of a MIMO process. MIMO process, it is multi-input, multi-output process. So now coming to the first slide. So I have depicted here multi-input, multi-output couple tank system. So this couple tank system, it is abbreviated as CTS for simplicity. So now, as you can see here, it consists of 2 tanks. So the first tank, it is having a cross-sectional area of A1 and A2. There are 2 tanks. And here you can see that coupling between the 2 tanks. So there are 2 inlets, F in 1 to the tank 1 and F in 2. F in 2 is the flow rate input to the tank 1 and F in 2 is the flow rate input to the tank 2. And again, this is the reservoir by which two pumps, they are pumping inlet flow to the tank 1 as well as the tank 2. So this coupling dynamics or coupling coefficient, it alone introduces the multi-input, multi-output nature of this coupled tank system. So whenever when the inlet flow it increases, the height of the tank 1 it will also increase. Since there is coupling interaction between the two tanks, the level in the F into it also automatically varies, irrelevant of the pump to inlet. Similarly, if F into increases as the height of the second liquid column increases, the first liquid column it also increases. Thereby, there becomes interaction. This is called interaction. And since both the two tanks they are coupled, the coupling dynamics they comes into the effect, which gives us that multi-input, multi-output nature. First, what we did was we went for a mathematical modeling. So the mathematical modeling it was made to find out the height of the first tank with respect to time. So there will be few things. So the inlet flow into the tank, the outlet from the tank, and the flow between the interacting tanks. So all those things they are modeled by means of the Bernoulli's equation 1 and 2 what I have given here. And again, the H1, H2, the parameters what I have used in those equations, H1, H2 are the level of liquids in the first tank as well as in the second tank in so much of meters. A1, A2, they are the cross-sectional area of the first as well as the second tanks. And F in 1 and F in 2, as I told before, they are the inflow to tank 1 and tank 2. They will be in cubic meters per second. And F out on F02, they are nothing but the outflow rate from first tank as well as the second tank. So U of T, it is the input voltage, what we are giving to the pump 1 and pump 2. Pump 1 and pump 2, they are nothing but the input voltages. And A1, A2, they are the cross-section areas of tank 1 and 2. And beta 1, 2, the centermost value, this beta 1, 2, it is the valve opening ratio between the two tanks. And beta 1, beta 2, they are the valve opening ratio for the two independent tanks. And K, it is the pump gain, and G is the earth gravity. So if we go on to design a conventional proportional plus integral control for a MIMO system, so these are all the design challenges. So the interaction between the two tanks it definitely poses a problem in order to design a classical or conventional PA control. So the non-linearity present in the system it poses a critical challenge, and the dynamic coupling interaction between the tank 1 and tank 2 it also yields a definite problem, yeah, as far as design is concerned, as well as the modeling and system identification. So modeling means I need to find out the exact parameters of the tank. I need to exactly find what is the area of cross section, total inlet, total outflow rate. So everything it has to be known before. So that will be a problem. And only when those things are known, I can effectively design a system to control that. Under the PA gains, it will be a problem because since the level of the tanks, they will be dynamically varying with respect to the each and every level of the tank, it also poses a problem. Under the disturbance selection, it will be definite. It also will be a definite problem. So the real-time performance bottleneck in this PA control design, it will be since the two tanks level continuously changes, real-time monitoring has to be done, and the PA control it has to continuously vary its controller parameters in order to have effective control. So we went for some conventional PA control design called by the name as a biggest log modulus tuning. So and again from those tuning methods adapted in one different paper from us. So the corresponding loop 1 and the loop 2 values. That is KP1, it is the proportional gain of loop 1, controller 1, and K1, it is the integral gain of controller 1. They are found as these values. And for loop 2, the proportional gain for controller 2 and the integral gain for controller 2, they are found as this value. So here what I have done is, so this is for this pink color, it represents tank 1. So I have changed the set point, that is set point means from where the actual level to which level we want to raise. So that set point it is changed from 18.32 centimeters to 25 centimeters. And again, while the tank 2 it is maintained at its nominal operating point. So we have maintained it at its nominal operating point. So for this range, the corresponding controller outputs they are given here. So since there is a change in the level of tank 1, so the controller output it increases and it decreases in order to stabilize the level of tank 2. This is called a servo response. This is for step change in tank 1. And for tank 2, what we did is this blue color. So in the level it has been changed from 12.23 centimeters to 17.23 centimeters, while the tank 1 it was level of tank 1 it was maintained constant. For this controller output it is now depicted as here. So now the performance metrics, we are going for two performance metrics, integral square error and integral absolute error. Both these things are time integral performance criteria. For both the loops, they are measured. Now we move on to bio-inspired algorithm. So the bio-inspired algorithms, they do mimic mechanisms found in nature, evolution of species, hunting behavior of animals, or collective intelligence of social insects, bees, swarms, whatever it is. So examples include gray wolf, particle swarm, ant colony optimization, whale optimization, firefly algorithm, artificial firefly algorithm, elephant herd algorithm. There are many more algorithms. So what we took was a cuckoo search algorithm. This cuckoo search algorithm, it is nothing but a bio-inspired meta-heuristic optimization technique or a bio-inspired algorithm. So it is based on the brood parasitism behavior of certain cuckoo birds. So what those cuckoo birds they will be doing is they will be laying their eggs in the nest of other host birds. If the host bird discovers that the eggs they are not its own, either they will be throwing it away or they will abandon that nest. So this natural behavior, when combined with Levy flight random walks, it forms the basis of the bio-inspired cuckoo search algorithm. Let me give the key concepts behind cuckoo behavior. Each and every cuckoo, they will be offering us a definite solution in the search space. The algorithm, it mainly consists of just three rules. Each cuckoo, it can lay only one egg at a time. That is, it can generate only one solution. And that egg, it will be placed in any one randomly chosen nest. The best nest with the high quality solutions based on the fitness function, they will be carried over to the next generation. So the fraction of nest with the worst fitness, they will be either abandoned or it replaced by the newly generated results. Next comes the Levy flight. So the new solutions which are generated using Levy flights, a random walk characterized by step lengths, it will be obtained from a Levy character distribution. In this equation, alpha is the scaling factor and lambda is the parameter controlling the Levy distribution. And this xi of t plus 1, it is the updated solution. So for abandonment, a parameter called as parameter p, probability of abandonment, it will be replaced with the new random solutions. It is ensured to increase the diversity as well as to avoid any premature convergence. And this is the cuckoo search path. So this L1, L2, they are the Levy flights, and the C1, C2 are the cuckoos 1, 2. So they search for the best nest, and again they do hatch, and the next generation siblings they are just produced. So the step-by-step procedure, what happens behind the cuckoo search algorithm for implementing it in a MIMO couple tank system is, first of all, we need to define the system dynamics. That is, we need to get a clear mathematical model. So we need to develop the nonlinear differential equations, what you have already done for a classical controller. And again, we are going to simulate this model using real-time evaluation for controller performance. The second step is to define the PA controller structure. We need to define the controllers, proportional controller gain 1, gain 2, integral controller gain 1 and gain 2 for both the tanks. Next, we need to define the optimization problem. We are going to choose two performance indices, as I already told, integral of square error IAC and integral of absolute error IAE. So next, we need to specify the search space. The lower and upper bounds, they are to be given. Usually any range in between 15 to 40, it is deemed to be advisable as far as cuckoo search algorithm is concerned. So next we initialize the cuckoo search algorithm. We generate an initial population of nest. Each nest, it will be giving us a potential candidate solution. So randomly we will be initializing this with the controller values with the predefined bounds. The fifth step, it is to simulate and evaluate the fitness for each solution. For each solution of that is the nest, we need to calculate the fitness function, and we need to arrive at the performance of IAC and IAE. Next step is to generate new solutions by making a Levy flight as given in equation 3. So we need to evaluate the fitness of the new solution. If the fitness improves, means what we should do is we should replace the existing nest with the new solution, or else we retain and go for the next iteration. And the next step, it is to abandon poor solutions. Whenever the probability of abandonment rate is more, we need to replace the worst performing nest with the new randomly generated solution within the search space. So this is to improve the diversity as well as to avoid any premature convergence. Next one is to update the best solutions. The best fitness score, that is with the lowest objective function, it is to be identified, and the optimal solution, it has to be retained for the current iteration. The last but one step is convergence check. We need to repeat steps 5 to 8 until the stopping criterion is met and the maximum number of iterations is reached, as well as the minimal improvement in the fitness function between the iterations. And the last step, it is to extract the optical parameters. And the next with the best fitness represents the optimal PA control parameters represented by KP1 star, KP2 star, K1 star, and K2 star. So the bio-inspired cuckoo search algorithm, as derived from the brood parasitism behavior of cuckoo birds, it tries to balance that exploration and exploitation to efficiently traverse the entire search space. As far as natural process is concerned, the cuckoos lay egg in their host nest, with the poorly adapted solutions being just thrown away, and under the fitness solution, it is enhanced by the Levy flight based random walks. So this definitely improves the optimization. In our cuckoo search based PA tuning, each and every nest, it represents a candidate set of controller gains. I'll be getting one set of control gains for the MIMO system. And the algorithm, what it does, it will aim to minimize an objective function, typically the IAC as well as the IAE. So these things, they act together to enhance control precision as well as the receptiveness. So it
Sorry
just
for the
starts.
interruption. This is just a reminder for the 12 minutes time limit.
Yes, ma'am. So this optimization, it will start by initializing a population of nest. So and again, the entire process, it will be carried out. So as far as the coming to the simulation results. So what we have done is, so we have employed the cuckoo search algorithm in MATLAB or Simulink. The algorithm as well as the entire mathematical model, it has been implemented in Simulink. And again, the simulation result, what I have shown, it is for a set point change in tank 2. So as you can see here, the set point change in tank, the tank 1 level, it is maintained. This blue line, it is maintained constant at 18.32 centimeters, whereas the set point change in tank 2, it is raised from that 12.23 centimeters to a maximum of 17.23 centimeters in tank 2, and the corresponding controller output, it is depicted in the figure 5. This is controller output for our cuckoo search algorithm. And the next simulation result is for set point change in tank 1. Here, the tank 2 level, it is maintained at its nominal operating point of 12.23 centimeters. This is 12.23 centimeters. Now for tank 1 only, it is maintained, it is increased from 18.232 to 23.32 centimeters, and the corresponding control outputs are presented here. So now I have tabulated the results of IAC as well as the IAE for this cuckoo search algorithm. And next we go on to the performance measure for this too. So the comparative results and discussion, this slide is for comparative results and discussion. So the first figure, it is for set point change in loop 1, that is for tank 1, and the next one is for loop 1 tank 1. This is for IAE and this is for IAC. As you can see here, so this cuckoo search, it outperforms the conventional control by a very, very huge margin. So this is 251 point.
Excuse me, sir.
Yes,
I'm
ma'am.
sorry, but you have crossed the 12 minutes mark. I would request you to kindly conclude the presentation.
Yes, ma'am. Yes, ma'am. So and again, this is the first comparative result, and this is the second comparative result. And again, the ultimate thing what we have found out is the cuckoo search, it performs very well in order to getting a lower ISC as well as the IAS values, and is a reliable solution for advanced MIMO control systems. These are my references. So now the session is open for queries.
Thank you so much, sir. Are
Thank
there
you,
any
ma'am.
questions? Are there any questions?
No question.
Okay. Ma'am, you have joined. Welcome, ma'am, to the session.
Thank you, Priyanshi.
If you can just maybe share a couple of words before we proceed. I think earlier you were not there, so I missed asking for your hello.
Hello. Yes, Priyanshi, as of now, you can proceed with the next presenter.
Okay, ma'am. Okay. Thank you
Ma'am,
so much,
ma'am,
sir, for
yeah,
your
ma'am. I would like to thank the team MCT4SD 2025 for this stupendous organization. And whenever we do mail for a query, immediately it will be addressed. And thanks, ton for those efforts, ma'am. Thank you.
Thank you.
moving forward. I request to kind of personalized we have. Is anyone else from the team present?
Hello, madam. Can you hear me? Hello, madam. Hello.
Yes, sir. I
Hello.
can.
Yeah, this is Arogya Swami, madam. I'm presenting a paper on leveraging AI-driven upskill and reskilling strategies. Ma'am, you are not audible.
Sir, he will be called upon as in queue.
Yeah, no problem. I just wanted to
So,
let you know that I'm there because you asked, is there anyone present here?
so is this
Priyanshi, the screen is not visible. For now, I'll share the screen. You can present.
hello. Okay, thanks, Anisha. Can you please present? All right. So I already called for Ma'am Shreya Yelne. Is available or should we move forward? I think we will move forward. I would like to request Sir Man Hyung to kindly present his for the commercial territory design problem. Do we have you here with us, sir? Anisha, am I audible?
Yes, sure.
Okay, let's wait me a moment.
Okay, sir, sure. Anisha, I think you can stop presenting. He'll share his screen. He's there, he's there.
Hello, just
Sir, can
I'll share my screen. I'm Maria Todorova. I'm a PhD student in Technical University of Varna. So thank you
I'm
for
sorry,
this
ma'am.
conversation.
I'm sorry, ma'am. I'm sorry, ma'am. I'm sorry.
Did you hear me good?
Just a second. Anisha, can you coordinate?
Yeah, wait. So I guess the previous presenter isn't present right
This
now in the
is
session. So just give me a second. I'll
they are
show the
not
flyer.
present and the paper being
Yeah.
yeah.
Yeah, so we can go ahead with the presentation of Mariella with the paper title.
The previous presenter is available. I think they are in the call and they said to present. Ekbar, can you go to the back slide?
Sure.
Okay, can I start?
Ma'am, just give us a moment, please.
Okay.
You guys are done.
Just a moment, ma'am. Sir Man Hyung, are you available and are you presenting? Anisha, I think let's take the next presenter. There is no response. Or wait, someone is sharing the screen. You're not audible, sir.
Can you see my sign?
Yes, now you're audible and now your screen is visible. You can start your presentation.
What's evening?
Ma'am Mariella, just a second. Ma'am Mariella, we'll take your presentation after this. Thank you.
Okay, thank you.
Yes, please start.
Yes. Good afternoon, ladies and gentlemen. My name is Hong, and I'm presenting Hanoi University of Science and Technology and Hanoi Ascension University. Today, I'm blessed to present our research title on efficient random VNS. Our team for commercial tutorial design problem. This work focus on optimizing tutorials prediction course starts in logistics and sales management. Let's start by defining the problem. We model the commercial tutorial design problem, CTDP on graph this, where we present customer loads and represent the connection between them. Each load has special activity attributes such as workload and demand. Our objects are to break these as nodes into distinct cluster tutorial. To be any solution, three conditional must be met. Each distance contains a design central node. Work nodes balance. The total activity in each district must be balanced within a special tolerance. Collectivity. All nodes in districts must be connected. And finally, we minimize the total distance from all nodes to their respective center. Why is this research significant? The CTDP has wide practical apply, especially in delivery service tutorial design, commercial tutorial design, and even political literature. Our main contribution in this paper is a new algorithm that affects balance and diversification, exploring new areas and intensification. This allows us to solve large-scale instance competitively against state-of-art model. Let's look this into optimization channels. As mentioned, our mathematical goes to maximize total compactness. However, critical constraints must be satisfied. Workload balance attribute total must fall within strict total range. Collectivity almost within a district must be collected. Our goal propose infection and meta-heuristics for large-scale instance, and else where the number of nodes is greater than 500. To take this, we propose a random VNS, at least the traditional VNDs with source neighborhoods in a fixed order. Our random VND randomly serves the order of neighborhoods operation in each interest. Thus, make explore neighborhoods operator to ensure intensification. The list of neighborhoods operates is served after each interest to each diversification. Our algorithm until four neighborhoods operates will choose well-known standards operates relocate and move a single border loss from DI to adjacent disease. Swap exchange two border loss between adjacent tricks. However, the levels of our approval lie in these two new operator change center. Recompute the tricks center for a trick, move subtree, move an anti-collected component of nodes to label tricks. This is the power of REST to make large structural chain while maintaining collectivity. Now, next, evaluate the performance. First, for small instances up to 150 nodes, we compare our result with the exact methods MTDP proposed by Sandra and Colin in 2011. As you can see the table, our random VNDs perform exceptionally well. We address optimal solution for almost all datasets. We reach solution very quickly compared to reference methods MCTP. This confirms our proposed Venice production and competitive efficiently. The most critical result is on large-scale instance where many heuristics are needed to fail. We compare our random VNDs against the state-of-the-art heuristics reposed by Physics and Risk in 2019. The result is clear. A solution quality random VNDs outperform the existing algorithm on a snap instant. Its improved web solution quality is better by 1.39 to 5.44. Conclusion, random VND is one of the most appreciated algorithms for server large-scale CTDB. Finally, we conducted a sensitive analysis to understand why our algorithms work. This is our key role. Real quest use most frequencies provide the last total reduction. Muscle tree provide a significant impact per year. A summary is balance contribute relocate for local reference, a muscle tree for struct escape. To conclude my presence, we have successfully developed randomized VNDs for CTDP. We introduce two new operators like chain center or move subtree. In the future, our experience show significant improvement of up to 5.54 over state-of-the-art model as not dataset. We believe this can yield to other complex existing problems like political, healthcare, and logistics. Thank you for listening.
Thank you so much, sir, for your wonderful presentation. Since there are no questions, we will be moving forward. Next up, I would like to request Ma'am Mariella
Hello, madam,
Kororova to
can you hear
kindly
me? Can you hear me?
Hello.
Yes, ma'am.
Okay.
Yes, ma'am.
This is a question for
Yes, we
the
are all.
last candidate.
Yes, ma'am. Yes, Kavita, ma'am.
Yeah. Let me know the main features, ma'am. What is the main
Okay.
novelty you have used?
Sir Manhyun, I think it's a question for you. You can answer.
Can you repeat, please?
Yeah, what is your main novelty?
Ma'am, it's for the previous presenter.
Oh,
Previous presentation. Just a previous presentation. What is the main multi-constraint optimal challenge? What is the main contribution they have used?
Sir Manhyun, are you there? You are on mute.
Excuse me.
think there are Kavita ma'am.
Yes, ma'am.
There are some network issues with the previous presenter, I guess. They are not
Okay,
able to
okay, madam.
respond. Can we proceed with the next presenter?
Yes, ma'am. Yes, madam. Yes, madam. Proceed, ma'am. Next candidate. Yes, madam.
All right. Thank you. I would like to request Ma'am Mariela Todorova to kindly present her paper titled Application of Laser Engraving in the Finishing and Personalization of Products Created by Vacuum.
Okay, thank you. So I'm going to share my screen.
Yes, please.
I hope we are here good. Thank you for this conversation.
Yes, ma'am.
So,
We are good.
okay, dear colleagues, today I will present a study focused on the application of laser engraving in the finishing and personalization of products created through vacuum casting. The aim of this work is to demonstrate how these two technologies can be effectively combined to achieve precision, individuality, and high aesthetic value in the final products. The main types of personalization made possible by laser engraving, inscription, logos, decorative elements, and various combined graphics. This versatility makes the technology suitable for both unique single-piece orders and for serial production, where speed and repeatability are essential. The study focused on two primary materials, metal and ABS plastic, as they are among the most commonly used materials in plaques, statuettes, and awards components. A fiber laser was used for the experiments, which provides excellent engraving results on both metal and ABS. You can see several practical engraving tests where different graphic elements were engraved: regular, italic, and bold text, contour-only images, combined elements, and logos. Each example was produced using different settings for power, intensity, and speed to demonstrate how these parameters influence the visual output. On metal, the difference appeared mainly as stronger or whiter contrast, while ABS plastic offers additional tonal variations and softer visual effect. Here you can see the permanently engraving tests performed on simple plates. These tests highlight the importance of selecting optimal laser parameters before mass production. When the settings are incorrect, the results can be seen in the next example: engraving that are too fine and difficult to read, or burned and destroyed elements with loss of details. After determining the optimal settings, a final product was created: a round ABS plate with laser engraved inscription, combined with a dolphin figure cast through vacuum casting. This finished result is shown here. The combination of the two technologies provides both high structural detail and customized surface personalization, enhancing the uniqueness of the value of the final piece. In conclusion, this study demonstrates that laser engraving is a reliable and highly adaptable method for the personalization of products produced by vacuum casting. It offers precision, repeatability, and a wide range of visual effects, while enabling a seamless integration of digital control and artistic expression. Thank you for your attention.
Thank you so much, ma'am, for your presentation. Are there any questions?
Yes, madam. This is Kavita from Chennai Institute of Technology. I have one
Yes,
question. Let me know, this is like a literature survey, isn't it, ma'am? Have you tested via the standard data sets. Go for your
Excuse me.
objective. Kindly
Can
go
you
for your
repeat?
objective.
Sorry, can you repeat the question?
Yeah. Please go for your objective slide.
You want to share again?
Yeah.
Okay.
Go for your objective. Let me know.
Second, this one.
Yeah, mainly focus on metal, ABS plastic using the fiber laser and achieve the high quality engraving on both material. How many use cases you have tested? Let me know.
What is the
How many cases you have tested or how many samples you have utilized for your implementation?
samples? We made a few samples because we need to test the different parameters like speed, intensity, and power. Because
Okay.
in different materials, the results are different with different settings also.
Okay. So one more suggestion to you, kindly go for a real-time sample, then only you can able to know how your implemented work is good in all areas. So please look on all these sample, that is very important, and highlight your contribution when you are presenting. What is the important thing which is available in your proposed work? That is very important. Okay, so
Yes.
these are the things should be included. Yeah, thank you.
Okay, thank you.
Thank you for the presentation. Now we'll be moving forward to the next presenter. We have Silvio Simani with the paper titled Artificial Intelligence Tools for Wind Farm Fault Diagnosis.
Good morning everyone. Good afternoon. I'm going to share Okay, can you?
Yes, the screen is visible.
Okay, thank you. So this is a joint work among several colleagues and students. A student from the University of, the University College of London, and another one visiting my university. And his supervisor, Professor Manchu from Japan, and myself, I'm professor at the University of Ferrara. So this work concerned the development of artificial intelligence tools for application to the full diagnosis of wind farm. Just a second, because it seems that doesn't. Okay. No, I don't know why. Okay. So these are the points of my contribution. We developed a new tool, which was based on support vector machines and a decision tree system for detecting and also isolating faults concerning affecting this wind turbine. And another important point of this methodology is that we tried, because we know that normally artificial intelligence tools are able to provide some answers, but without offering an interpretation of the results. So through the use of also of decision trees, we tried to provide also a motivation, an insight to this tool. Excuse me, I'm going to, because it seems okay, I skipped a little. So And so it's why this methodology is quite important, and it tries to overcome also some limitations of traditional deep learning methodologies. So the application is a benchmark which was developed specifically for a meeting which was organized in Cyprus 2025 this year, and it was trying to describe the behavior of a floating offshore wind farm. So some colleagues from Cyprus developed this benchmark, which is still freely available on the web. We are trying to, with other colleagues from Denmark, to improve also the faults which affects this benchmark. So for the next IFAC World Congress in Korea next year, we also provide a more accurate and complete simulator for a specific competition which was proposed for this benchmark. So it's why we are introducing realistic dynamic behavior, several faults, realistic faults, and a complete description of this benchmark. This is a short description of the benchmark, which contains several wind turbines. The benchmark includes also previous models of onshore wind turbines, which were adapted to this new benchmark. We have different faults. For this work, we considered perhaps which because it was representing excuse me, a starting point, an initial point for our investigation, we considered only a few faults or a couple of faults, for example, sensor fault and actuator faults, because they were the simplest to be detected and isolated, and especially if we aimed to develop a system which was able also to motivate our solutions. For the next version of the benchmark, we are including more other realistic faults. So it's why the model contribution was based on a selection of statistical features from the signals generated from this benchmark. We proposed the integration of decision trees and support vector machines, because in this way we were able to provide an interpretable machine learning approach. So when we mean machine learning, also intend to consider a data-driven approach. To me, the most important point is the practical interpretability, because when through the use of a decision tree mechanism, you are also able to perhaps acquire a deeper insight into your system and a clearer interpretation of your diagnostic decisions. Well, the starting point was the generation of a residual. So the residual is a symptom which is basically used for fault diagnosis. In principle, residuals fluctuate around 0. So it's really difficult to understand simply by checking the residual itself, the signal, if there is a fault. So it's why from these residuals, we need to extract some meaningful features. We considered 4 important main features: a residual mean shift, because it tries to capture the, let's say, the offsets generated by the faults. A variation in the variance, which is another effect of faults. Another important factor is the loss of the autocorrelation, because we know that normally when the conditions of the normal condition of the system are changed, also the autocorrelation deviates from the let's say white noise traditional assumptions of the residual. And another last important feature is represented by the spectral entropy, which quantifies, let's say, the variations in the frequency domain, which is another aspect which perhaps is introducing, for example, some, I don't know, vibration effects generated by the faults. This is an example of a picture of which helps to understand the different behavior of these features, depending, for example, on the normal case in blue, and in orange, for example, depending due to hydraulic faults, converter faults in green, and electric generator faults in red. So the classification was based on an ensemble method relying on decision tree and support vector machines. Is a complementary strategy, because the decision tree provides a transparent interpretability, while the support vector machines approach, which is used for managing the feature, ensures a robust, let's say, behavior. So the optimization was based on a gradient-based search, which was used for optimizing, for example, the thresholds for the decision of the decision tree, and as a whole approach led to a fusion rule, which included an integration of these decisions provided by the decision tree and the support vector machine. So this is also ensure a robust decision of the approach. So as a general description, of course, is quite complicated, and cannot be anything, everything cannot be described in this presentation. So for more technical questions, is better to check the paper. So normally we use a number of data for the validation, the training, and the test of our system. We use a number of 5 for the cross-validation in order to ensure the robustness and the generalizability of our system. We optimize the regularization parameter and the kernel width using the test data, and so the metrics in order to validate, which represented also the, let's say, the criteria for the final also validation of the solutions proposed for this competition. We considered the meaningful metrics such as fault detection rate, false alarm rate, false positive rate, and fault latency. So as a final result, we got compared with respect to traditional solution, for example, based on traditional approach, which were quite simple, as, for example, relying on a very simple detection thresholds, we got the solutions highlighted as in red here. And as you can see, we were able to obtain a detection rate which was larger than 90%, which quite low false alarm rate and as a false positive rate, and with the lowest detection latency of about 2.3 seconds. So as a final, let's say, summary or consideration, this joint methodology was able to significantly outperform conventional, for example, simple, for example, geometric thresholds and single decision tree and support vector machine solutions. So as accuracy, we got that the highest one was more than 90% and with very good reliability also. We saw here that the approach was also able to show, which represent the, let's say, some areas for further improving this methodology, the analysis of the reliability and the robustness with respect to traditional approaches. And this approach, which integrates decision trees and support vector machines, demonstrated to get the most robust and reliable solution. Further research directions, as I mentioned at the beginning of the presentation. So we are trying to expand the methodology to different cases of faults, which will be shown at the next IFAC World Congress in Korea. Normally is a usual aim, so to try to deploy these approaches to real wind turbine systems, and including in the new version of the benchmark more severe conditions of the sea in order to further evaluate the robustness of our methodology. And potentially, this approach can be extended, for example, to other systems, energy conversion systems, I mean, like wave or tidal energy conversion systems. And as a final remark, so consider not only the detection, but also the isolation applied to a broader set of faults. So I think that, so these are the final points. So we proposed an interpretable decision tree and support vector machine methodology. We tried to, we seems be able to demonstrate the superiority of our methodology for the practical and easy diagnostic tool for detecting faults. And I think this is all. Thank you for your attention.
Okay, sir, I have 2 questions to you.
Yeah.
Actually, you have used like a statistical feature named as a signal based on features. Can you use it for some other features also? Is it suitable? Or only used for statistical based signal based features, sir? Any other features we can able to utilize?
Yeah, we are trying. I think we are because these features they have some limitations, especially when because normally you assume that the signals that we are considering are almost stationary, So we need to consider some other features, for example, including some other nonlinear effects which normally are not well shown with this feature. So is another, I think is a very important remark from your side. Is it represents also a limitation of the current approach.
Okay.
So is you are right. We need to consider other statistical, let's say, metrics or features. Yes.
Okay. Sir, one more thing. Actually, in this, your approaches can be used for tackling all kind of challenges like wind and temperature and icing, etc. Everything, sir.
I think yes. If we are able to find the connection between the, let's say, the fault and its effect to a measurable index, in principle, which represents also a limitation of these approaches, in principle, you are able to detect and also isolate every kind of fault in principle.
Okay. Let me know your accuracy, sir. What is accuracy you have obtained via your model? Like you have mentioned, demonstrated superior performance for FDR as well as FAR and latency. Let me know the accuracy, sir, when compared with the existing model. What is the accuracy of your proposed model overall?
Yeah, the accuracy, well, as a whole, I can say there are different indices. Normally, for example, you can consider, of course, it depends on, normally we are evaluating the accuracy depending on the reconstruction error of these, of when you model the system. So normally the accuracy, there are different kinds of accuracy. One is that, for example, the accuracy regarding the model reality mismatch. So as an average, we can say that the accuracy is larger than, higher than 90% when you consider the description, the modeling as a percentage of the data that are correctly described by our model. This is normally the accuracy. The other kind of accuracy is referred to the detection or fault diagnosis capabilities, which is also very high. And in this case, normally as accuracy is reflected to the indices like the false alarm rate, the true detection rate, which is really high, very high in this case. Normally, these two performances are they are correlated.
Okay. Thank you, sir. Thank you. Thank you for the
You're
clarification.
welcome. Thank you.
I
Thank
wish
you
you
for.
all the best. Thank you, sir. Thank you.
Thank you. You too. Thank you.
Thank you so much for the presentation. Now we'll be moving on to the next presenter. Next up, we have G. Anusha with the paper titled FinBot Revolutionizing Banking Through AI. Do we have G. Anusha in this session? Or any of the co-author of the paper? Since there's no response, we'll be moving forward to the next presenter. We have Milfy James I. Antonio with the paper titled Smart Care and IoT-based automated sprinkler system with temperature, humidity, and ammonia monitoring in small-scale piggery coops.
Good day, ma'am.
Yeah.
Okay, so good day to each and everyone. So I am Milfy James in San Antonio, and I am here to present our research entitled Smart Care and IoT-based automated sprinkler system with temperature, humidity, and ammonia monitoring in small-scale piggery coops. So small-scale pig farmers often rely on manual methods to cool the pigs and monitor temperature, humidity, and ammonia levels inside the coop. These traditional practices requires time and constant attention, leading to inconsistent conditions that can harm animal welfare and reduce productivity. Research shows that ammonia levels about 20 parts per million already pose health risks, and poor cooling practices can cause stress. While automated systems exist in larger farms, they are usually too expensive, complex, or lacking in environmental monitoring features. This leaves small-scale piggeries without a practical solution that can maintain safe conditions and improve daily operations. So Smart Care was developed to address this gap by providing an IoT-based system that automatically manages cooling and monitors temperature, humidity, and ammonia levels. The system activates sprinklers based on heat trends, follows a 2-minute spray and 50-minute drying cycle, and records sensor data every 5 minutes. A web application allows owner to monitor conditions, adjust settings, view logs, manage vaccination schedules, and receive SMS alerts when ammonia becomes unsafe or when sensors malfunction. Field deployment in Barangay Lumad, Pagadian City showed stable monitoring, effective cooling, and water safe level management, and timely ammonia notifications. So the Smart Care is developed with the goal of providing small scale of pig farms a practical, user-friendly, and dependable tool for improving livestock welfare. So the design of Smart Care is built on 4 key principles. So the system prioritizes maintaining safe levels of temperature, humidity, and ammonia inside the pig co-op. This ensures that the environment remains healthy and comfortable for the animals. Efficiency. By automating monitoring and sprinkler activation, the system reduces the need for manual labor. Farmers can rely on Smart Care to manage routine tasks such as cooling air, quality regulation. So reliability. Smart Care uses rule-based logic, meaning its decisions and responses are timely. This ensures that critical actions such as activating sprinklers or sending alerts happen when needed. Scalability. The system is designed to grow with the farmer's needs. Additional sensors, features, or mobile app integration can be added in the future without overhauling the entire setup. So these are the rule-based algorithms. So the system begins by initializing sensor readings and first checks the ammonia concentration level using the MQ135 sensor. If the ammonia level reaches or exceeds to 20 parts per million, an immediate SMS alert is sent to the farmer via GSM module. So if the ammonia level is normal, the system evaluates temperature data taking every 5 minutes. If the readings show a consistent rising trend, the system proceeds to check the water tank level. If the water tank level is low, it triggers a refill action. Otherwise, it activates the sprinkler system to cool the pigs by spraying for 2 minutes, followed by a 15-minute drying period. So if the temperature condition is not met, the system checks the water level again and either refills the tank if necessary or activates the sprinkler if conditions are appropriate. So these rules ensure precise environmental control for pig welfare while optimizing water usage and maintaining sensor-driven decision-making consistency. So this is the system architecture. So I use ESP32D as the microcontroller, and I use sensors such as relays for switch on and off, logical converter to convert the electric current, the DHT11 for temperature and humidity, and MQ135 for NH3 or ammonia monitoring, and HCSR04 for water tank level. So we use three water pumps, and our source of water is from the well, and it fills water to the tank. If the tank is 20% or below, then the microcontroller is connected to Wi-Fi and it go to that database, and it can be used via the web app. So this is the user system consideration. So this is the user interface. So as you can see, there's a temperature, humidity, ammonia reading, and the water tank and drinker tank. And the statistics tab, you can see the temperature, humidity level over time, and you can also filter it for 1 hour, 1 day, or 1 week. So this is the historical reading. So it prints data every 5 minutes. So every 5 minutes you could see the temperature, humidity, the ammonia, and the water tank level data. So this is the system setting. So this is where the user can manually deactivate the sensor readings, or they can also deactivate the automated sprinkling. System evaluation results using Likert scale. So based on the table, the user find the system reliable, functional, and easy to use. So the conceptual impact. So SmartCare provides low-cost IoT alternative, much cheaper than the commercial systems, sustainable features through the role-based logic, useful for rural and small farm settings. So the SmartCare system is an IoT-based sprinkling system for small pig farms that can monitor levels of temperature, humidity, and ammonia. Its functions are automatic sprinkling, SMS alerts for ammonia levels, and a schedule that takes pig vaccination into account. The system presents how technology can help farmers in rural areas improve the health of animals, make jobs easier, and take care of their livestock. So conclusion, SmartCare integrates sensors, a rule-based algorithm, and a web interface to improve pig welfare and farm efficiency. Designed for small-scale pig farms facing heat stress, ammonia buildup, and inefficient manual cooling. Key features included automated water refilling, SMS alerts, and scheduling that considers pig vaccination periods, demonstrate that IoT can significantly enhance farm productivity, automation, and overall animal welfare. Future work, conduct long-term field testing to evaluate system stability, reliability, and performance in real farm conditions. Refine sensor thresholds, sprinkler schedules, and alert triggers through continuous monitoring across seasons. So optimize system speed, responsiveness, and usability on both web dashboard and IoT modules. Expand testing to multiple pig pens for scalability assessment. Further improve features for better service to small piggery operations, including stronger ammonia monitoring and enhanced alert mechanisms. So that would be all. Thank you for your attention.
Okay, and you know, I have a good presentation. I have two questions for you. Actually, what is the range of sensor you have? So here in this work, the sensor is taking the major role and important contribution also. Let me know the accuracy or sensor capacity.
We test the sensor accuracy, and we use temperature and humidity detector, and as we compare both, it it is not quite very similar sa accuracy, but it's right there, like it's accurate, but not very the same as the detector, but it's close.
Okay, so what are the environmental interfluence will be available in this in your application? What is a environmental inter fusional are available in your project? Let me know.
Can you repeat, ma'am? Sorry.
So environmental challenges. What are the environmental challenges you have faced? Interference.
About weather, ma'am.
Okay. So none of the challenges.
So far, only the environmental challenges, ma'am.
Okay, okay. Right. Good work, ma'am. Thank you.
Thank you, ma'am.
Thank you for the presentation. Now we'll be moving on to the next presentation. Next up, we have Amit Upadhyay with the paper titled Two Population Hypothesis Testing from Image Data Using Named Entity Recognition and Random Forest Classification. Do we have Amit in the session? Well, it seems the author is not present in the session. So I'd just like to call the two presenters which were previously absent, Shreya Yelne and G. Anusha, if they are present in the session, else we'll be moving on to the next. Well, I believe none of them is here. So we have one more presenter from the previous session who couldn't present there. So we'll be taking, if the session chair allows, can we take him here in the session?
Yeah, sure, madam.
Yeah, so we have Arogya Swami Karadi with the paper titled Leveraging AI-Driven Upskilling and Reskilling Strategies for Employee Retention and Internal Mobility, an Empirical Analysis Across Key Industries.
Can you hear me? Can you hear me, madam? Am I audible?
Yes, you're audible. You can
I'm
present.
sharing my document. I'm sharing my document in a minute.
I hope the screen is visible now.
Yes, madam, it is very much visible for me.
So you can start your presentation.
Sir, it's visible. You can start now. Please proceed.
Yes. Madam, this is Arogya Swami. I'm talking to you from India, Karnataka. I'm working in Kerala Technological University. My paper title is Leveraging AI-Driven Upskilling and Reskilling Strategies for Employee Retention and Internal Mobility, madam. It is an empirical research. We took IT industries, manufacturing industries, service industries, out of which 120 are the non-managerial employees we have taken as samples. Coming to objectives, we just wanted to check it out how the AI-driven training can influence the retention. We just wanted to find out the differences in learning sector-wise, and we wanted to find the relationship between the reskilling and internal mobility between the mid-level and non-level dressing. So the objectives are three. Coming back to methodologies, we have got 45% of the data from IT sector, 27.5% of the data or the sample from services, and 27.5 from manufacturing. We have used descriptive statistics, correlation, regression, and ANOVA for our statistical testing. And we have used PSPP softwares for our testings. The key descriptive methods are mean learning participation score, that is LPS, we call it as 59.57. The mean reskilling score, that is RS, is 57.9. The average experience of the people whom we took as a sample are 15 years of age. And we find a strong relationship between the learning participation score and retention score. The correlation is 0.736. So we experience weakly related retention between retention through the AI-driven skilling and reskilling, madam. Coming to what our regression findings told us is learning participation score is significantly predicted retentions, and our B is 0.603 and P is lesser than 0.01. Experience not significant, that is P is equal to 0.75. Model explains the 54.3 variance, and that is R square is equal to 0.537. To give you more ideas about the data, what we had and the analysis we had was industry does not moderate the learning participation score and the retention score relationship at all. Effects are consistent across all sectors, and the model, that is R square is equal to 0.54. Our ANOVA results had showed no significant difference in learning participation score and across the industries, and there was no more significant difference in retention score across the industries. Uniform AI learning adoptions and outcomes are important when it comes to analysis. The conclusion is that AI-driven learning is a stronger predictor of retention. Skill relevance outweighs our tenure, and upskilling and enhances internal mobility, builds confidence and adaptability. And to give you more of explanation to the analysis, what we have done is we have done a sample distribution and correlation matrix. In IT sector, we have got a frequency of 54 and percentage is 45%, and learning participation score is 1 and retention score is 7.36. Then in our research, we came to know that average learning participation score and retention score collected from employees across sector, such as manufacturing, IT service sector, the mean value for LPS achieved in the study of 57.77 and standard deviation was 13.68. Retention score had a mean value of 57.99 and standard deviation was 11.16. The workforce was found a high average tenure and years experience amid mainly centered around 15 years, madam. And our research also made us to understand IT sector, that is 45% of the total sample, followed by service and manufacturing sector, that is 27.5 individually. The majority of the respondents held a bachelor's degree, that is 53.33, and the study also revealed a strong positive correlation of 0.736 between learning participation and retention score, which implies that higher learning engagement is strongly associated with better retention. On the other hand, also experience of the employees, that is 15 years of experience, also showed negligible correlation between the learning participation score and retention scores. And when it comes to multiple linear regression, we came to know that employee retention within the organization, is a driver. The regression model results obtained was found to be highly statistically very significant, and learning participation score was found to be significant positive predictor. Then the experience of the employee, on the other hand, was not found to be statistically significant. That is, retention score was 0.027, which highlights that the tenure of an employee in an organization doesn't independently drive any retention. And when it comes to conclusion, the study findings are disclosed that the learning participation score is a very important indicator of employee retention and stresses the strategic impact of AI-driven upskilling and reskilling initiatives on employees' learning efficacy and organizational coordinations, madam. Our research indicates also a strong correlation between the individual's learning potential score and human capital matrix, madam. It implies that the learning participation score is a reliable predictor of workforce competency. The theories what we have currently regarding this reskilling and skilling theories, the dynamic capacity, we have given attention to the critical role of continuous knowledge accumulation and skill adaptability in employee turnover and organizational flexibility. Interestingly, the study that we did was outcome reveals that a time of employees' involvement in the organization has a negligible impact on retention rates. This indicates that a significant shift in the modern dynamic job market, where century-old followed employment models may be becoming irrelevant. In today's labor market, madam, industries are preferring certain skills to traditional metrics like years of experience. But this shift is initiated by the fast-going digital transformation, we understand, and the aggressiveness integration of artificial intelligence across industries. It makes permanent learning a vital requirement of employees to prove themselves relevant and value adding to their roles. Our research proved that the positive relationship between the engagement in AI-driven education and employee retention in various industry sectors. The execution of AI-enhanced learning systems can lead to an employee confidence in job security. It facilitates internal career growth, and it also guarantees the workforce capabilities align with evolving business needs today, where innovation is a major factor. In a long last, madam, the study also finds out that it emphasizes the critical need for organizations increase investment in adaptable, data-informed platforms that encourage and implement continuous skill development. By this research, we can also give some scope for the future research, where you can drive the research towards how the organization culture and managerial support tempers outcomes in upskilling and reskilling initiatives across diverse industries and global regions. A deep understanding of effective influence of these initiatives could be facilitated by the inclusion of cultural factors, leading theories such as transformational leadership or relevant leadership, and technological leadership as a traditional moderator and mediator in the future studies, madam. We at the end would like to put a point that employees' learning engagement is a worldwide accepted driver of retention across various industry settings. Our study perhaps highlighted that the tenure of an employee has a negligible direct influence on organization. This study further also, helps to enhance the growing body of knowledge and how the human technologies synergy changes across different geographical areas and industries. Madam, this is what we wanted to put to your table, and we are very open for any type of clarification or the mathematical queries you have, madam. Thank you for this opportunity, madam.
Sir, I have only one question.
Please.
Sir, currently we are working in colleges or industry. We are in so many pressures. So how we can
Yes,
able to compensate with the work-life balance between the industry? Because nowadays, even though the faculty member is working in a college, also we are in like a industrial
yes.
working culture. So how we can able to manage with the work-life balance between the industry as well as college and home?
Yes, ma'am. Madam, it's a very interesting question, especially for the person who is working in education institution. So
Yes.
teachers are usually, they work before the duty starts. They are working at the time of duty. They also work after the duty completed.
Yes,
So
yes.
yeah, I mean to say you have to prepare for your classes and you have to deliver your class. And after the delivery of the class is done, you have to go for the other, no, academic related works like corrections and other things. I don't want to tell you go because you already been there in that field. The only thing what I can tell in a very general way is that a man has to decide, divide the whole 24 hours into 8 hours. For example,
Yes.
8 hours you take perfect rest, and 8 hours you spend it for your personal life, and 8 hours you have to spend for your profession. It all depends on how do you manage your time within the prescribed format. For example, 8 hours I'm working for an university, how best I make use of every minute, that will not that will help me to not to disturb my personal life when I go back home after my job. But at the same time, madam, it also depends on how your authorities are dealing with you, how the system of the university in which you're working. See, sometimes we would like to have only 8 hours of the serious work and go back home and forget the work life. But sometimes the assignments that are given and the targets that are given, and also the technical inculcation that is happening in the universities today. For example, you have come across a national credits framework we have. We have come across so many credit works, all the government related aspects that has to be inculcated in the education. It is quite difficult. I too strongly believe, madam, that the work-life balance is all about a mental status. For example, if I start taking it as a stress for me after I go back home, and it is a stress, if I start enjoying the work that is, coming on my table after my work is done, if I start enjoying it, doesn't look so much stress. So the stress, I strongly believe it is in your head. Can I give you a small example, madam, if I've got another minute?
No, sir, it's enough. Sir, one more thing,
Yeah.
only one thing. So, how to prepare, how your model will be preparing for industrial readiness of the faculty member, and how you are tackling with the toxic people like industries or some in a working environment. How to handle with these? Do you have any one of the module or any one suggestion like that in your work for
Madam, look
industrial
what is
readiness
happening.
for a
Yes,
faculty member?
surely,
Industrial.
surely, madam. Surely, madam. See, madam, we work in three different areas. One is we work towards the management, we work towards the teaching faculty, and we also work towards the students. When it comes to teaching faculties, madam, we have got all the technological aspects that will make our teaching faculties more stronger and deliver the content to the students in a very stronger way. And when it comes to students, madam, it is not only that nowadays we are teaching the syllabus and sending the students. University should also come forward to give them the industry, no certification courses where the hands-on experiences. We should make this, no, for there is a concept called as a self-study, and there is also a concept called as a self-learning, and we have got team learning. When we do all these type of things at the time of the students spending their time in the university or in the college, so along with your teaching them the academical and education related things inside the classroom, we are also letting the students to go out of the campus and start working in the industry. For example, we have got projects, we have got mini projects. We also go send the students for internships. We make the industry experts to come inside your organization and give us some deliver some guest lectures, and we can also make the people understand what are the new technologies that are adopted in the industries today. So you can integrate both the education institution and the corporate outside, so that the students are ready at the time of second year, third year, fourth year only to go and start working in the corporates. That is one way we can get our faculty plus our students ready for the industry, technology driven world, madam.
Yeah. Thank you, sir. Thank you so much,
Yes,
sir. Thank you for the nice explanation. Wish you all the best, sir. Thank you.
thank you so much, Kavita madam. Thanks a lot. Namaste.
Thank you so much for the presentation. So with that, we have completed all the presentations for this session, and I would like to close the session now. And I sincerely thank all our authors for their excellent presentation and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for you all. We, on behalf of the whole team, we thank you for your support during this version of the conference and all the previous versions as well. We will be happy to have you in the next version in 2026. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. So kindly cooperate with the team of MCT4SD 2025. In the end, I'd also like to thank our session chair for chairing this session. And this is a small token of appreciation on behalf of the team of MCT4SD and Global Knowledge Research Foundation. Thank you so much for your presence, ma'am. Ma'am, you're on mute.
Yeah, thank you, madam. Thank you so much.
Yeah, so now I'll just request you all to please turn on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. Thank you. See you all
Thank you.
soon. Yeah. Bye-bye.